So the third step is you need to plot your data points. So you use a fine point or pencil when trying to do this particular part. So with a well sharpened pencil, lightly draw a smooth curve. So remember that generally not all of the curve that you're gonna be graphing is in the form of straight line. It could be obviously a line. It could be as a parabolic or sinusoidal in nature or any function. That so smooth curve that fits the small circles. So again, if all the data points, if you see that the general trend is a straight line, you use a straight line. If uh, the data points form a parabola, then draw a parabola. So make sure that you don't need to try to force your line to go through all the dots. And again, that is to expected if you're doing certain experiments, because in experiments you will have uh, certain errors, and that's fine. So if the points seem to lie in a straight line, use a ruler, preferably a transparent one, so that you can see all the points while selecting the best line. So the best line that would fit all these small circles or your data points, the one that you plotted. Sometimes a point obvious has no experimental error, so the line must go through it. Okay, so let's say for example, what I mean is that if your somehow data points are something like this, so if you can see generally that is just the curve that best fit with this one is a straight line. So you use a straight line. I'm gonna use a ruler and then draw the best line that I can draw. That means that again, when you're drawing the straight line, it doesn't necessarily hit all your points. So if you can see here, this doesn't hit that line, but that's how you're gonna do it properly. Don't connect them each of the data point. So it should just be the curve that fits. That means that uh, generally fits the trend of the data points that you have. So let's try to apply this one into an example. So we have given here time and velocity. So we use the symbol t for time and then velocity v, and then their corresponding units are seconds for time and meters per seconds for the velocity. So again, if you're gonna go through the different steps, uh, first step is we need to identify which of these two variables are your independent and the dependent variable. So in this case, if you can see, well, this is a particular data wherein you set the time at, you try to set a particular time 0, 1, 2, 3, 4, and 5 seconds, and you try to measure the velocity. So therefore, in this case, my independent variable is the time. The dependent, and this is my independent variable. So this means that this would represent the time quantity, would represent the values along x. And obviously, well, velocity would be my other variable or the dependent variable. So in this case, this is the one that I measured in a particular experiment. I measure the velocity of the object at certain times. So uh, now I have my independent and dependent variables. So I'll just get draw my Cartesian coordinate system. So again, my Cartesian coordinate system is this consists of two lines, one vertical. So I'm going to use a ruler and then draw a straight line. So one vertical and the other one horizontal. So again, as much as possible, I'm gonna use the the space that I'm given. Like if you can use all the space, much better. So again, as I've mentioned, my independent variable or the data that could be placed along x is the time. So I'm gonna place t, and then this is seconds. Again, it should be written this way: t as the symbol of the quantity and s for the time. In my y-axis is my dependent variable, which is my velocity, and the unit is given in meters per seconds. So I'm gonna write m over second, and again I'm gonna write it in a close, open and close parenthesis, so in brackets. So the reader would say, okay, you're using the quantity v, and then the unit is meters per second. Okay. Now the next step is choosing the correct axis, and no, the correct scaling, or the scaling that I need to use. So again, remember that I need to uh, maximize my space. So part of doing, so that I'll know what would be my correct scaling, I need to know my minimum and maximum value. So if you can see, the time has a minimum value of 0 and a maximum value of 5. So therefore, I'm gonna take into account that one. So let's say my maximum is only 5. So therefore, perhaps I can use a scale of just 1 second. So if you can see, the space from 0 to 1 is 3 boxes. So that means that I also gonna need, or gonna need to use the same space, the same distance from 1. And again, the scale is 1 plus 1 is 2. 1, 2, 3. So this is 3, then 4, then 5. And I can stop at 5, or if you want, well, that's 1, 2, 3, 1, 2, 3. 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. Or you can stop at 6. Okay, that would be enough, because anyway, in our data, the maximum value of the time is just 5 seconds. Now for the meter, for the velocity. So here's a thing: you don't necessarily use the same scale. Whatever you use in your x-axis, you don't have to use that one in your y-axis. So somehow they're independent with one another in terms of the scaling. So you wouldn't mind using a different scale with this, with your velocity. So again, the maximum. So if you can see, they have different maximum. 9.9 for velocity, minimum the same as 0. So if I'm gonna use a scale of 1 and then gonna use the same distances, it wouldn't fit in my graph. So therefore, to I'm just gonna try to count the number of boxes that I have along the y-axis, and then use the scale that fits up to 9.9. So I can actually have 1 to 3, but this time I'm gonna use a scale of 2, 3, and then this becomes 4.0 to 3. This would be 6.0, 8.0 to 3. It would be 10.0, and then so I can just stop at 11.0 or 11. Okay. So now I have my scaling. So if you can see, the scale of the time, quantity time is 1, but for my velocity it's 2. So anyway, again, you can do that one. They should not be 11, but they should be 12. So just be careful with that. Remember, equal distances. So that means that since my scale is 2, so that means that if you can see how many boxes did I how many boxes I used here. 1, 2, 3, 1, 2, 3. So again, from 2, 4, 6, 8, 10, and 12, they're equally spaced from one division to the other.